Hello everybody. In this video I am going to show you how to factor trinomials without a leading coefficient or when the leading coefficient is 1, which really means the same thing. So I'm going to begin by doing this first example problem, which is x squared plus 7x plus 10. This is a trinomial because it has 3 terms and its leading coefficient right here is a 1. So this is a pretty simple factoring problem. I would classify this under the easy realm. And how do you start this? I start it by creating a FOIL problem. I hope you remember FOIL. First, outers, inners, last. It's a little acronym to help us remember how to multiply 2 binomials. The result is the problem I'm started with, and I got to go back and get the answer. Why would we need to do this? Well, I'll show you later in the year, but as of right now, we're just going to practice this skill. The result of multiplying the 2 first pieces, which this is the first piece and this is the first piece, gives me x squared. So that really is a no-brainer. The only thing to do is x times x. It's really easy when that leading coefficient is a 1. Then the thing that's weird here is I skip over this middle term and I go to the last term. That is a result of these last terms here. So what times what is 10? Well, I have 2 options, 1 times 10 and 2 times 5. Little strategy here is try to pick the ones closer together. They are often the answer. The probability of it being 2 and 5 is way larger than it being 1 and 10, the way most textbooks are written. However, you got to check them all just in case. So in this case, it is 2 times 5. Now, why is it 2 times 5? Since 1 times 10 also gives you 10. That goes with the middle term. The outers and inners result when you add them is got to be 7x. So what are the outers? It's these 2. Outside, if you look at all 4 of these, the ones way on the outside are 5 times x, which is 5x. And the inside, these 2 on the inside here, are 2 times x, which is 2x. The only way to get 7 in the middle and 10 at the end is to add these 2 and get 7x and multiply them to get 10. And now these are all pluses, so the only way to really put this in here together is x plus 2 and x plus 5. So that is my result. So this end piece here, this is my answer to the factored form of this original piece. Why would I want to do that? Well, of course, I'll show you later. This is just skill building. Well, here's number 2, which is very simple also. It's a little bit more difficult because of the negative signs. So I'm going to change this into a binomial, and you're going to notice I stick with the same method. That method is start with the first. The only thing to get x squared is x and x. Then I move to the last. And in this case, there's only 2 possibilities also. You either have 1 times 8 or 2 times 4. Now, normally I say start with the ones closer together. So if I did put a 2 here and I did put a 4 here, that is going to be wrong, and I can kind of see that because I have a middle term of 7. 2x and 4x, no matter if one of them's negative or both of them are negative or neither is negative, there's no way I can get 7x. So I'm going to kind of erase that piece and erase this piece, and I'm going to go back and I'm going to say, all right, now it can't be that one. And sometimes this happens with factoring where you just kind of guess and check. So I'm going to go with the 1 and the 8. Could it be the 8 and the 1? Well, since these are both x, it doesn't matter. How am I going to combine my outers and inners to get negative 7? Let's see here. Well, if the 1 is positive and the 8 is negative, the outers produce negative 8x. The inners produce positive 1x. When I combine these by adding, negative 8 plus 1 is negative 7. And that, lo and behold, will give me my entire result. So this is the correct answer. This would be my preferred way I'd recommend that you factor trinomials. Some of you may have come from an algebra class where you might have used the diamond method or the diamond game. That's certainly an acceptable strategy, but the only reason I don't really care for it too much is I kind of forget where the numbers go. I believe the way this works is that the last term goes there, negative 8. The middle term goes here, negative 7, and you play a little game here. What times what is 8? That adds to 7. Well, the only way to do that is 8 and 1, and how do I get a negative 7? That'd be a negative 8 and a positive 1. This then would give you the results of these 2 pieces, and then you just fill them in with the x's. You can certainly use the diamond game. I will never tell you you cannot, but often in class I will rarely use it just because it's kind of cumbersome for me and it's usually easier for me just to play around with the parentheses until I get it correct. But by all means, it's accurate math, so if you want to use it, go ahead. This is the last one I'm going to show you, which is another pretty easy one. It is a little different, however, because I'm going to start with the no-brainer of x and x. Notice my theme, start with the first one, move to the last one, skip the -5 for a moment. Now, the 6. Well, I got two choices, 1 times 6 or 2 times 3. The tricky part of this one is, if I started with the 2 and the 3, which would be my gut feeling, I could say, yes, I could get a -5 if these are both negatives. Because outers would produce -2x, inners would produce -3x. -2x, when you add to -3x, does give me a -5x. Do you see why that is wrong, however? Why is it wrong? Well, the reason why it's wrong is you got to make sure you do the entire FOIL to check. So let's do the FOIL. First, x squared, check. Outers, -2x, inners, -3x, -5x, check. And here it comes the tricky, the last. -3 times -2 is a +6. Uh-oh, I need a -6. It does not check. Sorry, doesn't work. So I bet it's got to be the 1 and the 6 because that also produces the same answer. So x and x gives me x squared. Move to the last. If the 2 and 3 didn't work, why don't I try the 6 and 1? The way to get -5 is make that a negative and make that a positive. Now if I check my FOIL, my first is x squared. My outers is plus x, 1x. My inners is minus 6x. My last is -6 times +1 is -6. Is this the same as my original starting value? Well, when I add the middles, +1 and -6, I do get that magic -5x. Everything else checks out. I'll be explaining to you over the next couple weeks as to why you would want to factor, but factoring is an essential tool that's needed in all upper level math all the way through calculus. So that's how you factor. I hope you got something out of this. Now it's time to go practice your skills. Thanks for listening.